Hi everybody, today we're going to have a look at how tables and graphs align with our coordinate geometry knowledge. So in coordinate geometry, a graph is a collection of points or lines. Line graphs can be drawn on a Cartesian plane, and we can use these for displaying data. A table can be useful for displaying data prior to graphing. So I'm going to show this through a series of examples. The first example is a lemonade stand. We want to make up to 100 cups of lemonade, and it costs us $10 for all the materials to buy those 100 cups. We want to know how many cups are required to break even if we charge $1 per cup, $2 per cup, or 50 cents per cup. Now I've put that information into this table here. The information in here is the revenue, over here is the cost, and over here is the number of cups we make. Now anytime we make more than $10, we're making some profit. At $10 we're breaking even. So if we charge $1 for 1 cup, it's going to cost us $1. For 5 cups it would cost us $5, and for 10 cups it would cost us $10. So here is our break-even point. For $1, the break-even point occurs at 10,10. For $2, for 1 cup we would charge $2. For 4 cups we'd charge $8, and for 5 cups we'd charge $10. That's our break-even point. So that would be at the point 5,10. For 50 cents, for $1 we would charge for 1 cup we would charge 50 cents. For 2 cups we would charge $1. For 5 cups we'd charge $2.50, and as we can see we haven't quite reached the break-even point with this table. But let's graph what we know so far. Here's the break-even line. Anytime we cross this line we've made $10. So with the dollar line, that's this black line here, for 1 cup it's $1. That's what we saw there. And for 2 cups it's $2. That's what we saw there. And if we continue that, we get this line here. And we can see that when we sell 10 cups, it costs $10 as per our break-even point. For $2 cups, for 1 cup it will cost $2. For 2 cups it will cost $4. For 5 cups it will cost $10. 5 cups, $10, that's our break-even point, 5,10. But 50 cents we can't quite see yet because we haven't graphed enough. So let's make the graph a little bit bigger. And we see here, if we extend the graph, we get to 20,10, indicating that for 20 cups we make $10. Now one way we could have done that is we could have graphed the first 4 points that we knew, drawn a line through it, and then inferred that where it crosses the break-even line, that's where we're going to make profit thereafter. Okay, so we have a solution for our first case, 5, 10, and 20, depending on how much we're charged. Now for example 2, we're interpreting some ice cream sales data. So in our ice cream sales data, in January we make this much per hour. Well, that's how many we sell per hour. Now if we look over here, 50s here, 0s here, each of these gradations is 20, or is 10, 10, 20, 30, 40, 50, 10. So we know that this point here represents January and selling 20 ice creams per hour on average. In February they sell 25. In March it looks like 22, and in April it looks like something like 15. They sell the most ice cream in February, and they sell the least ice cream in June. And in here I've drawn a line of best fit, which has as many points above it as below it. 6 points below, 6 points above. It's somewhere in there. Now this is only an approximation. You've got some great tools for finding a line of best fit later, but for now we can just put that in, and we're not going to comment too much on whether it's appropriate or not. So let's have a look. If that's where we have the most ice cream and that's where we have the least, if we need to justify whether the data comes from the northern or southern hemisphere, we need to think when it's hottest. And in the southern hemisphere where we live, it's hottest in February and it's coldest in June. So this data here would most likely be from the southern hemisphere. Now, we've been able to tell quite a lot from just looking at that graph. And that's pretty much what you have to do. You have to look at this axis and look at this axis and look at the title, and then analyze the information that you've been provided to answer questions. And with most data, it really requires you thinking that, does the data tell me what I think it does? So that's where we're going to leave it for today, and we'll look at tables and graphs in more detail in the next slide. Thank you, everybody.